In my previous two videos on protocols, I covered their purpose and design principles. I also presented an alternative approach, which you can use instead of protocols, and I explained the use cases of each of them. I think that by this point you've got a fairly good understanding of what protocols are and why we use them. So now let's have a look at protocols in Swift specifically. Hey, I'm Yakov, and this is another video in my Swift and iOS Basics series. This series is all about the fundamentals of software development, and it couldn't be more true about today's topic, because it's finally time to explore protocols in Swift, starting with the very fundamental questions. In this video, I'll cover how you declare protocols, how you conform objects to them, and how you call protocol methods. And spoiler alert, there's more than one way to do so, each with its own nuances. I know these things are kind of obvious, but they lay the foundation for a couple future videos on protocols. In them, I'll delve into generics, associated types, method dispatch, and more. Subscribe if you're interested in any of this. And now let's finally meet protocols in Swift. In many ways, protocols are similar to other objects you can create in your project: structures, classes, actors, and so on. The key difference is that you don't provide any implementations in protocols, only signatures of methods and properties. Actually, there are some useful exceptions to that, but I'll get back to them in the next video on protocols. Protocols can declare pretty much every kind of member a Swift object can have. That includes properties, methods, initializers, and so on. Moreover, a protocol can, for instance, require that its property is mutable, or that its method is asynchronous. To declare a protocol, you start with the protocol keyword, followed by the name. When you list a property as a protocol requirement, you have to mark it as either mutable or immutable. You use the get and set keywords for that. But keep in mind that if you don't include the set keyword, it doesn't mean that the conforming object must use a constant. It simply says that when this property is used through the protocol, it can only be read, but not written to. However, anyone who has direct access to the implementation can still change the value. When it comes to methods, you define them in the protocol like normal functions, only without curly braces. You only include the signature, but not the body. The method's parameters and return type are declared just as usual, and so are other details such as static, mutating, async, and throws. There's one important distinction between properties and methods. With properties, you can declare less but implement more. The protocol can require only read access, but the implementation can still be mutable. With methods, however, it's the other way around. For instance, if the protocol doesn't say that the method is asynchronous, then your implementation can't be async either. But you can declare more and implement less. A throwing method in the protocol can be implemented as a non-throwing, and an asynchronous requirement can be implemented by a synchronous method. Let's put all of this into practice. Here I have the bird protocol, and I'll go over some of my design decisions. First of all, each bird has a name, and the name is declared as an immutable property. In theory, the bird's name can change at some point, but that's between the bird and its owner. That is why protocol users don't have write access. The protocol also has two methods. Both are declared as async, and the fly method also has the throws keyword, because newly hatched birds can fly. In most cases, it's a good thing that any type can conform to any protocol. But in some situations, you actually want to limit that to only reference types, such as classes. That comes in handy when you need to make sure that your objects use reference semantics. For situations like this, you can restrict the scope of your protocol. You do that by putting this anyObject constraint after a colon. That's what I'm gonna do with my protocol, because the bird instance should be passed by reference. If you have no idea what I'm talking about, I can refer you to this video. With these tools and options, your protocols can be flexible and powerful, but without requiring too much of you at the time of implementation. So now let's talk about how you conform your objects to protocols, and how you implement their requirements. In the base case, any Swift type can conform to any protocol. That includes structures, classes, actors, and even enumerations. You can also make a built-in type conform to a protocol. That's because protocol conformance can be declared in an extension to that type. That means you don't need to modify its original declaration. If you want to modify it, you can, of course. But actually, declaring protocol conformances in extensions is a good practice. This way you can clearly see which properties and methods come from the protocol. Of course, there are exceptions. For instance, you can declare stored properties in type extensions. In the simplest case, I've got a protocol with only one method, and a structure that needs to conform to the protocol. Everything is really easy, so instead let's have a look at something more interesting. For instance, if I try to conform the same structure to the Burp protocol, the compiler won't let me. That's because I explicitly restricted its scope to reference types. So instead, I'll use a class. It already has the name property, so when I declare a protocol conformance, it will satisfy one of its requirements automatically. And it's totally fine that the protocol expects a constant while I've got a variable here. But the methods from the protocol don't exist in the class yet. In a previous video, I mentioned that protocols must be implemented in full, so my project won't build until I add the missing methods. Luckily, the compiler can figure out what's missing and add stops for me. However, before I try to build the code, I'd like to make some changes. Let's say I'm building a robotic bird. Such birds waste no time sleeping. In fact, they're always watching. The bird's battery can be swapped instantly, and because of that, making the sleep methods asynchronous is unnecessary. I can simply remove that keyword. Also, robobirds can fly from the moment they hatch, or get off the assembly line, so I don't need the throws keyword either. But watch what happens when I try to add something that wasn't in the protocol. The sleep method was declared as a non-throwing, and because of that, I can add the throws keyword in its implementation. That means if the bird's new battery fails, the sleep method can throw an error. Just as I mentioned, enumerations can also conform to protocols. Here's an example. Don't forget that Swift enums can have stored properties, and that sometimes limits your options. One thing you should be careful with is declaring protocol conformances for types you don't control. That applies to both built-in types and types which simply come from another module, like an open source package. Technically, nothing stops you from extending them like this. But also, nothing stops the original author from adding a symbol with the same name but different behavior. The compiler will mark your property or method as duplicate, but it won't highlight the calls to it. So in the best case scenario, you'll need to change every such line. And in the worst case, the behavior will change without you even noticing. That is to say, I don't recommend abusing this feature. Now that I've got a protocol and an object which conforms to it, I can finally start using its properties and methods. There are two ways you can work with protocols in Swift. You can use them as existential types or as generic constraints. This time I'll only show the first way because it's simpler, even though it's not always efficient. Just to clarify, I'm not saying that it's wrong or that you shouldn't use it. In fact, in some cases it's your only option. But keep in mind that there is a second way, and in a future episode I'll show it in detail and explain the difference. So, protocols as existential types essentially look and behave just like other objects, structures, classes, and everything else. You simply use the name of the protocol as the type of a property or function parameter. The any keyword is optional in situations like this. Of course, it doesn't exist for nothing, but again, I'll get back to it in another video. At this point, I can already access any property and call any method declared in the protocol. I can pass the protocol object as a function parameter or make it someone else's property. Keep in mind, however, that the protocol object's actual type is no longer visible to the compiler. From now on, I can only use the properties and methods declared in the protocol. So, for instance, if my class conforms to a protocol but also has some methods of its own, I won't be able to call them. That's part of the price you pay for the convenience of existential types. There are performance implications too, but I'll save them for another time. In my previous video, I explained inheritance as a paradigm that you can use instead of protocols. In that light, you might find surprising that protocols themselves support something that looks awfully like inheritance. It's not true inheritance, but it works in a similar way. One protocol can inherit all requirements from another protocol, and then add more requirements on top of that. Again, it's not true inheritance as with classes, and because of that, there's a few important differences. The key difference is the underlying mechanism. While a derived class points to its superclass, a derived protocol basically just copies all requirements of the super protocol. But that is a big topic, and I'll probably have a separate video about it in the future. In terms of actual use, there are two more prominent differences. First, protocols do allow multiple inheritance. Because protocols don't provide implementations, you don't face the diamond problem that I explained in the previous video. And second, protocols can't override other protocols' requirements. But again, you'd never need that because there's nothing to override. A more appropriate name for protocol inheritance is protocol composition. But in my experience, both terms are equally common. When it comes to conforming to compound protocols, it's basically the same as fulfilling the requirements of all its parts. In fact, your object can just conform to each of them individually, without ever mentioning the compound protocol. The compiler will synthesize the overall conformance behind the scenes. As the final topic for today, let's talk about a technique called protocol-oriented programming. It's not an entirely new concept in software development, but Swift takes it to a whole new level. Basically, it's one of key ideas of Swift. First and foremost, protocol-oriented programming can be viewed as an extension of the composition paradigm. I discussed it in the previous video. In short, composition favors the use of small and reusable components. The idea is that you use protocols to describe software components in terms of behavior. Then you can combine these protocols to get an object which does exactly what you want, no more and no less. But the tools available in Swift make achieving these goals much easier. For instance, value types and their ability to conform to protocols. They generally make your code simpler and faster. Instead of creating a class, providing a separate initializer, and employing reference semantics, you can get the desired behavior from a structure, or even an enumeration. Protocol composition, or inheritance, lets you combine individual requirements and avoid the unneeded complexity. This approach results in cleaner and more maintainable code. And protocol composition in Swift is enhanced by protocol extensions. They allow developers to provide default implementations for properties and methods. This means that a conforming type gets the desired behavior for free, and the same behavior can be shared by all conforming types. This effectively solves the code duplication problem and minimizes the risk of errors. Protocol extensions are a super powerful tool, and in future videos I'll have a closer look at them. And that's a wrap for today's video. In the next episode on protocols, I'll highlight a few more interesting topics, such as generic methods, associated types, and default implementations. Subscribe to this channel so you don't miss them. And if you found this video helpful, give it a thumbs up. Here's something you can watch right now. And until next time, make your protocols fly.